Welcome to another Curious Engineer video. In this video you will learn about the sound coverage study, a crucial analysis used to achieve optimal sound distribution and quality, using simulation software. Let's dive in. What is a sound coverage study? A sound coverage study is a comprehensive analysis conducted to evaluate the distribution and quality of sound within a specific area or venue. It involves assessing factors such as the reach, clarity, and uniformity of sound across different points within the designated space. The primary objectives of a sound coverage study typically include ensuring speech intelligibility in environments where verbal communication is essential, such as auditoriums, conference rooms, or public spaces. Ensuring that speech remains clear and understandable throughout the area is crucial. Optimizing music quality for venues hosting musical performances, concerts, or events. Achieving balanced sound distribution to enhance the listening experience of the audience is a priority. Enhancing safety announcements in settings like airports, train stations, or emergency facilities. It's vital to ensure that safety announcements and alerts are effectively conveyed to all occupants, regardless of their location within the premises. Conducting a sound coverage study using simulation software can be an effective and efficient way to analyze and optimize sound distribution in various environments. Here's a step-by-step guide on how to do it. Select simulation software. Choose a simulation software specifically designed for acoustic modeling and sound propagation analysis. Define objectives. Clearly outline the objectives of your study. Determine whether you're focusing on speech intelligibility, music quality, safety announcements, or a combination of factors. Understanding your goals will help you tailor the simulation parameters accordingly. Input environment parameters. Input detailed information about the environment you're studying into the simulation software. This includes the dimensions of the space, architectural features, materials used in construction, and the location of sound sources and receivers, e.g., microphones and audience areas. Set simulation parameters. Configure simulation parameters such as the frequency range, sound propagation model, e.g., ray tracing, image source method, and simulation duration. Adjust these parameters based on the specific characteristics of the environment and your study objectives. Run simulations. Run the simulation in the software to generate predictions of sound propagation throughout the environment. The software will calculate factors such as sound pressure levels, reverberation time, and direct-to-reverberant ratio at different locations within the space. The basis of all calculations is the so-called noise map. The noise map can be generated in two ways, either to measure it with calibrated noise level meters or to compute it with a noise mapping, noise prediction software program. The noise measurement can only be established on industrial plants if all machines and installations are in operation. The software calculation can only be executed if the data of all machines, buildings, structures, etc. is available. A typical noise map looks like this one. We can see different kind of noise sources: surface, point and/or line source. Different colors mean different noise levels. After generating the noise map, we can now begin with placing the speakers depending on hazardous or non-hazardous areas. There are several rules to be observed. Here are examples for the most important ones. The speakers should only cover the manned areas where workers could be present. We must be aware of too high sound pressure levels, e.g., above 120 decibels, due to potential hearing damages. At an ambient noise above 85 decibels, additional flashing beacons should be installed. It should be noted that while 85 decibels is generally acceptable, this number it is usually based upon client requirements and regulations. Vivo Asia has undertaken projects where it was required to install beacons for values above 80 decibels. Speakers should be mounted considering listener height. This is generally provided by the client. Hazardous areas with appropriate X-proof speakers. After placing and aligning the speakers, we calculate the sound map and at least the signal-to-noise map. Signal-to-noise ratio, or SNR, is a measure used in science and engineering that compares the level of a desired signal to the level of background noise. A high SNR means that the signal is clear and easy to detect or interpret, while a low SNR means that the signal is corrupted or obscured by noise and may be difficult to distinguish or recover. However, speech intelligibility is not dictated solely through the SNR. The RASTI calculation is also used for this. SNR can be improved by various methods, such as increasing the signal strength, reducing the noise level, filtering out unwanted noise, or using error correction techniques. The sound map represents the radiated sound of the speakers at the listening plane without noise, whereas the signal-to-noise ratio constitutes the result of a mathematical calculation. The signal-to-noise ratio should be greater than or equal to 10 decibels. This may differ from standard to standard, country to country, and customer to customer. The signal-to-noise ratio, SNR, should always be above 0 as the announcement should overpower noise. There is generally no upper limit to SNR. Vivo Asia commonly goes up to 35 to 45. This depends on the speaker tapping and noise of the area. A good SNR does not necessarily correlate to good speech intelligibility. Next, analyze the simulation results to assess the coverage and quality of sound within the environment. Identify areas with inadequate coverage, excessive reverberation, or other acoustic issues that may affect the intended use of the space. Based on the analysis, make adjustments to the design of the sound system or the layout of the environment to improve sound coverage and quality. Conducting a sound coverage study in an industrial setting can offer several significant benefits. Industrial environments often have high levels of noise generated by machinery, equipment, and processes. By conducting a sound coverage study, companies can ensure compliance with occupational health and safety regulations regarding permissible noise levels. This helps protect workers from potential hearing damage and reduces the risk of regulatory penalties. Excessive noise in the workplace can have adverse effects on employee health and well-being, leading to stress, fatigue, and decreased productivity. By identifying areas with high noise levels through a sound coverage study, employers can implement measures to mitigate noise exposure, such as installing sound barriers, acoustic enclosures, or providing personal protective equipment, PPE, like earplugs or earmuffs. Effective communication is essential in industrial settings to ensure smooth operations, coordination between workers, and emergency response. A sound coverage study helps identify areas where communication may be hindered by excessive noise, allowing companies to implement solutions such as strategically placing communication devices, installing intercom systems, or using noise-canceling technology to improve clarity and intelligibility. Abnormal sounds emitted by machinery or equipment can indicate potential malfunctions or maintenance issues. By conducting a sound coverage study, companies can monitor and analyze the acoustic signatures of equipment in real time, enabling early detection of anomalies and proactive maintenance interventions to prevent costly breakdowns and downtime. Industrial noise can also have environmental implications, affecting nearby communities and wildlife habitats. By assessing sound coverage and implementing sound control measures, companies can minimize noise pollution and mitigate their environmental impact, contributing to corporate social responsibility efforts and maintaining positive relationships with stakeholders. Overall, conducting a sound coverage study in an industrial setting can lead to improved safety, productivity, environmental sustainability, and regulatory compliance, ultimately benefiting employees, stakeholders, and the organization as a whole. Subscribe to our channel for more engineering and industry videos.